Everything you think you know about the Big Bang might be wrong. Everything has a beginning, and the same is the case with the universe. The Big Bang Theory happens to be the most accepted scientific theory when it comes to the origin of everything. No, it was not an explosion like what you believe, but merely an expansion of the space between matter. However, there are astronomers and cosmologists who still can't make peace with this theory. When scientists and astronomers talk about an expanding universe, you might think, what exactly is the universe expanding into? What exactly is the Big Bang Theory? Is there something beyond our universe? Well, there are so many questions that we need to find answers for. So keep watching till the end to know more about the origin of the universe and why the Big Bang Theory could be misleading. The Big Bang Theory is by far the most compelling explanation we have for the early development of the universe. According to this theory, the universe expanded from an extremely hot, small and dense state, and ever since then, it expanded and became less dense and cooled down over a span of millions of years. But what evidence do we have to support the Big Bang Theory? Well, we have two major scientific discoveries that provide strong support for the Big Bang Theory. We have Hubble's discovery in the 1920s, where he discovered the relationship between a galaxy's distance from Earth and its speed. Then you have a discovery of cosmic microwave background radiation in the 1960s. The size of everything in the universe is controlled by the strength of fundamental forces that hold atoms and subatomic particles together, and as far as we know, things have not changed much. Instead, it's the space between galaxies that's been increasing as they are getting farther apart because the universe in itself is expanding. But how exactly do we know that the universe is expanding? Well, during the early 20th century, the universe was thought to be static, meaning it's always the same size where there is no expansion or contraction. But things changed in 1924 when astronomer Edwin Hubble used the technique pioneered by Henrietta Leavitt to measure distances to remote objects in the sky from Earth. Hubble used spectroscopic redshift data to measure the speeds these objects were traveling, then measure their distance from Earth against their speed. That's when he discovered the speed at which the astronomical objects move apart is proportional to their distance from each other. In simple words, the farther away objects are from us, the faster they are moving away from us. This is now known as the Hubble law. The relationship Hubble discovered was later used as the evidence for the expansion of the universe. Imagine the galaxies as a few dots on the surface of a balloon. It doesn't matter what dot you choose, every dot is moving away from it, and the dots farthest away are moving even faster. The surface of the balloon is an expanding, two-dimensional shape, while on the other hand, the universe is expanding in three or more dimensions. The balloon also expands into existing space, while the universe expands into itself, at least with our very limited knowledge. Edwin Hubble also realized that distant objects he had been observing lay far beyond the Milky Way. This was also the very first time humans discovered that structures existed outside the Milky Way. Today, we know that the objects that Hubble observed are galaxies, similar to our own Milky Way, and there are more than billions of them just in our observable universe. For those of you who don't know, the observable universe, as the name suggests, is the universe that we can observe all thanks to the light that reaches to the Earth. Hubble's discovery provided additional evidence for what was later known as the Big Bang, which was first proposed by Georges Lemaitre in 1927, which marked one huge step forward for astronomy. About 380,000 years after the Big Bang, the universe became transparent light, and for the next several billion years, gravity slowed the expansion of the universe. Just about 8 billion years after the Big Bang, expansion of the universe began to accelerate, and cosmologists believe that it is all due to the effect of something known as the dark energy, which is causing the universe to expand by making matter repel other matter. But everything surrounding dark energy is a total mystery, just like most other things about the cosmos. Cosmologists were able to calculate the theoretical temperature of today's universe and began to search for evidence for it. It was eventually discovered by accident in 1964 by Arno Penzias and Robert Wilson as a noise in an antenna they had built to research how radio signals could be reflected off of orbiting satellites. They initially thought that it was radio interference from nearby New York City, but eventually they recognized they were onto something big, as this radiation was from far beyond the Milky Way. Today, the cosmic microwave background radiation is very cold due to expansion and cooling of the universe, and it fills the entire universe and can be detected day and night in every part of the sky. Now, if the universe is expanding, what is it expanding into? Is there something beyond our universe? Well, the galaxies outside our own are moving away from us, and the ones that are farthest away from us are moving even faster. This means that no matter what galaxy you happen to be in, all the galaxies that you see are moving away from you. But these galaxies are not moving through space. They are moving in space because the space in itself is also moving. This simply means that the universe has no center and everything is moving away from everything else. The universe, as you know, encompasses everything in existence, all the way from the smallest atom to the largest galaxy that we had the privilege to discover. The only part of the universe that we know is called the observable universe, which is the region around the Earth where light could reach us. One of the best ways to explain the expanding universe is to imagine the universe like a loaf of raisin bread dough. As the bread dough rises and expands, the raisins will move farther away from each other, but they will still be inside the dough. In the case of the universe, there may be more raisins or galaxies out there, but we simply cannot see anymore because they moved away so fast that light has never reached Earth. But luckily, gravity has always been in control of things at the local level, and that's what keeps all the raisins, or in our case, the galaxies, together. Scientists now revealed that the expansion is slowing down because of the effects of gravity, and the universe may expand to eternity. New studies on supernovae and a force known as dark energy may modify the possible fate of the universe. But if the Big Bang Theory is backed by a lot of evidence, why do few other astronomers and cosmologists reject the idea of an expanding universe? There are several observations that do not support an expanding universe, which could disprove the Big Bang. So, the real crisis in cosmology would be the fact that the Big Bang never happened in the first place. The Big Bang Theory states that any super-hot explosion throughout the universe would have generated a certain small amount of light element lithium and large amounts of helium. But when astronomers observed older galaxies, the amount of lithium observed was lower, and in the older stars, it's just about 1/10 of the predicted level. The oldest stars just near to us have less than half the amount of the helium predicted. Next comes the antimatter and matter annihilation. Since the intense radiation of the Big Bang produces matter and antimatter in equal amounts, mutual annihilation of the particle-antiparticle pairs might reduce the surviving matter density to around 10 to the power of -17 protons per cubic centimeter. But observations have a different story to tell. The matter density in the universe is observed to be about 10 to the power of -7 ions per cubic centimeter, which is more than 10 billion times higher than any Big Bang prediction. Big Bang proponents have proposed some unknown asymmetry between matter and antimatter, which would lead to more production of matter, but this has never been observed in laboratory experiments. Next, you have the surface brightness because, in an expanding universe, an optical illusion makes objects at high redshift appear larger and dimmer, so their surface brightness, which is the ratio of apparent brightness to apparent area, declines sharply with redshift. Based on observations of thousands of galaxies, surface brightness is completely consistent with distance, as expected in a universe that is not expanding. According to the Big Bang Theory, the universe is supposed to start out completely smooth and homogeneous, and grow in size over time. But according to the observations, we already discovered huge structures of galaxies which are too large to be formed in the time since the Big Bang. And finally, we have to discuss dark matter. According to the Big Bang Theory, it requires the existence of dark matter, which are extremely mysterious particles that we may never have observed in the laboratory, despite spending several resources to learn more about them. According to observations and multiple lines of evidence, especially observation of the motion of galaxies, this dark matter might not simply exist, and it's just something that we made up altogether. Extremely sensitive telescopes on Earth have failed to detect dark matter particles. But this also could be due to the fact that we may not have the kind of technology to deal with dark matter yet. But if dark matter existed, it would create a viscosity effect on galaxies that would prevent the existence of the many long-lived groups of galaxies that are observed. Right now, you can simply deny the fact that the Big Bang Theory is the most compelling explanation for the creation of the universe, and it will continue to be that way for the foreseeable future until we find anomalies within this theory as we improve our technology. It might be easier for us to explain about the beginning of the universe and the Big Bang Theory than talk about the future of the universe. The universe might even last forever, but we may never know. Or it could be crushed out of existence, all thanks to something known as a reverse Big Bang effect.